Now let's talk about graphing using slope-intercept form. Using a table is always going to be a great tool to have in case of any equation or any function you're trying to graph. You can always use a table. But sometimes it's nice having techniques that can help you graph some of your equations a little bit faster. And this is one of them. So slope-intercept form is very specific. Your y needs to be isolated. Your slope and your x and your y-intercept are on one side. Remember, this represents your slope, which is rise over run. B is your y-intercept, which, remember, y-intercept is a point, meaning it's 0 for the x, and then whatever number you see, whatever constant's there, that's your y value. But the y-intercept is not a number. It is an ordered pair. And these are going to be some steps that we can follow. You can use them or you don't have to. But the first step is to isolate your y. Once the y is isolated, meaning there's not a negative, some number, just y all by itself, you will be able to identify your slope and your y-intercept. And that's what step 2 is, to identify them. Once you do that, you're going to take that y-intercept, you're going to plot that point on your graph. And then step 4 is you're going to find a second point by applying the slope to the y-intercept, meaning your rise over your run, and that's going to create a second point, which is all you need to make your line. So here's the example. Again, we have this graph from before. Here it is. But we're going to have to isolate our y value. And to do that, I want to take care of the terms before I take care of the factors. And what are terms? Terms are separated by plus or minus signs. Factors are separated through multiplication. So I'm going to take care of this term first before I take care of this factor of -3 in front of the y. To do that, I need to subtract by 2x to both sides of this equation. I'm sure you remember people saying, when you do it one side of the equation, you have to do it to the other. And the idea is that you're balancing out the equation. When you balance it out, the equal is still true, still stands. The 2x cancels, and I'm going to be left with -3y equal to, now here, I'm going to rearrange the order because I want it in slope-intercept form, meaning I want the x term first. So that's going to be -2x plus 6. Why am I allowed to do this? You have to remember a property called the commutative property for addition. It tells us that a plus b is the same thing as b plus a, as long as you keep the sign of the number. What do I mean by that? If I had 2 minus 3, I'm not going to write 3 minus 2. That would be wrong. I would need to write -3 plus 2. That negative stays with the 3. The positive stays with the 2. That will give me the same answer because 2 minus 3 is -1. And -3 plus 2 is also -1. If you were to do 3 minus 2 instead, you would end up with a +1, not a -1. So you're allowed to change the order as long as you keep the sign of that number. But now I have to take care of the factor. Since I want to isolate the y completely, I need to make sure to divide by -3 to the entire left-hand side and the entire right-hand side. Now here, In the previous step, these two cancel each other out. Here they simplify, because negative 2x plus 2x is 0. Negative 3 divided by negative 3 is 1. So 1 cancels, 1 simplifies. So that leaves me with y is equal to, or y is equal to negative 2x plus 6 all over negative 3. Now, when you're dividing multiple terms in the numerator and have one single term in the denominator, you're allowed to split those terms. And the idea comes from, if I were to make a quick note, it's that a plus b over c is the same thing as a over c plus b over c, and vice versa. You can combine them or you can break them apart. Only if there's a single term in the denominator and multiple terms in the numerator, you can split each term to have the same denominator. It's like adding fractions backwards, because to add fractions, you want to have the same denominator, and then you combine it into one fraction. This allows you to work backwards from that idea. So, because I want to be able to identify my slope and y-intercept, that negative 3 in this denominator is stopping that. So I'm going to do y is equal to negative 2x over negative 3 plus 6 over negative 3. Now I know the two negatives are going to become positive, but this positive becomes a negative. Now I don't expect you to write so many steps, but I just want to show you how to identify each part. Now, 6 divided by negative 3 is negative 2. Now all I need is my slope, which is 2 over 3. And my y-intercept, remember it's an ordered pair, so it's 0, comma, and the constant here is negative 2. Now you want to be careful, because I know the slope we said is m. Now, at first glance, it looks like 2 is the only thing in front of them. But this 3 is also part of the coefficient of x. You can think about it like 2/3 x. Or you can write it as 2x over 3. They mean the same thing. But you want to make sure you can identify the entire slope and not just the number right in front. So like I said, what do we do next? We plot this point. Here's the point. And then my rise over run. So that means I'm going to go up 2. So that's positive. Go up 1, 2. And then write 3. Because it's positive. And positives are on the right. 1, 2, 3. And that, like I said, finds my second point. And now I can sketch the graph. And that's it. If you want to pause the video and try the next one, you can. But let me go through this a little bit quicker. So again, I'm going to isolate. I'm going to take care of the term first before the factor. And then the 4's cancel. It's going to leave me with 2y is equal to, once again, negative 4x plus 2. I rearranged the terms and make sure I kept the sign of that term. We divide to the left-hand side, and then we divide to the entire right-hand side. If you want to skip a step here, if you know this is eventually going to just be divided by 2, you can, if you can recognize that. If not, just take it step by step. Negative 4 divided by 2 is negative 2x, and 2 divided by 2 is positive 1. So my slope here is negative 2. But remember, slope is rise over run. So I can actually write this negative 2 over 1, and then I have a run that I can do. My y-intercept is going to be 0, comma, and the constant we have is 1. All I need to do now is plot my point at 0, 1. And then my rise, it doesn't go up. Since it's negative, I'm actually going to go down 1, 2. And it's a run for 1, so that means I'm going to go to the right 1. And then here is my graph. And that way we can use the slope-intercept form to sketch the graph. We'll talk about nonlinear functions next, and we'll also look at some of those techniques on how to do this.